Let us start study session 2, Quantitative Methods Basics. The first LOS, which is reading 5, is the time value of money. The value of money changes with time, and the underlying reason behind that is the interest rate. So in this topic, we will try to interpret interest rates as required rate of return, discount rate, or the opportunity cost of capital or money. Then we look at various components of interest rate as real risk rate. Then we will look at various components of interest rate such as real risk-free rate, expected inflation, and the premiums that are required to compensate the risk. Then we will look at the interpretation of effective annual rate based on various kinds of frequencies of compounding. Then we will try to solve certain problems of time value of money for different compounding periods. Then the calculation of present and future value for a single sum of money, for ordinary annuity, for a due annuity, perpetuity, and finally the series of unequal cash flows. We'll try to draw a timeline to understand the changing nature of value of money with time and solve a few problems. So let us start the topic. These are the three main interpretations of interest rate. First says required rate of return. So this is the rate of return which is required by the investors to lend their funds. So if investors are expecting this amount of return, they will invest the money in the particular project. If they are not expecting this minimum amount of return, they will not be interested in investing. The second interpretation is the discount rate. So this is the rate at which we try to discount the future value to convert it into present value, or for conversion to future value from the present value. For example, if we want to know what will be the value of $100 1 year from now, or what is the value of 100 rupees 1 year from now today. So if we want to have 100 rupees in future, what is the money to be kept today? So we have to use a discount rate. For example, the discount rate is 10%. So 1 year from now, the value of 100 rupees or $100 will be 110. Similarly, if we have 10% discount rate here, so the future value, which is 100, for that the present value will be 90.9. Let us look at the third interpretation, which says in terms of opportunity cost. It is the value foregone by the investor by choosing a particular project or course of action. For example, if I have an option to invest $100 in certain project of mine where I can earn say 15% return, but if I'm not investing in that and I'm investing in some other project which is coming to me, so this is the amount which will be foregone by me. So I will expect at least 15% on the new project, because this 15% is my opportunity cost of capital. So this is the opportunity I am losing. That is another interpretation of the interest rate. For all the calculations in finance, these interest rates will be used, and we can have any of these interpretations based on the context. The large meaning remains the same. Now let us look at the components of interest rate. How do we reach a particular number? We are talking about required nominal interest rate or discount rate or the opportunity cost of capital in nominal rupee or dollar terms, or the percentages. First of all is real risk-free rate. For example, if an household has $100 today and he has consumed $50 and savings are $50. So this person is not consuming whole $100, he's consuming only $50 and postponing the consumption of another $50 for the future. So for this postponement of consumption, he should be compensated, and that compensated will be real risk-free rate. Then comes the second factor, which is inflation. If this person is giving these $50 to some company or some other fund, the value of these $50 will fall with time due to inflation. So he deserves to be compensated for the inflation part as well. Then comes the third part, which is the default risk. There is a possibility that the company which is borrowing from this investor is not able to repay the interest or the principal itself. The company may default. Because of the default risk, again a premium is associated, so this investor has to be compensated for the default risk as well. So this also becomes a part of the interest which this person deserves. Fourth component is the liquidity premium. We take the same case. Suppose this person, say 6 months after investing this money, suddenly needs his money back because of some liquidity requirement, some income needs which suddenly arises. For that, he might not be able to sell the bond of the company or the share of the company or whatever is the instrument immediately. So there is a risk which this person is taking in terms of liquidity. For example, if he has invested in treasury bills, he might be able to convert that bill into cash almost immediately. So their liquidity risk remains very low. At the same time, if it is not very high grade corporate bond, then liquidity premium will be high. So the person should be compensated for the liquidity risk as well. So this is the fourth component in the interest rate. And finally, the maturity risk premium. This is another risk. This risk has to do with the fact that at the time of maturity, if the interest rates prevailing in the markets are higher than the interest rate given by that instrument, then the person tend to lose. So this is the maturity risk premium. So all of them together constitute the nominal interest rate on a particular security. So now let us look at a few other concepts. Firstly, effective annual rate. Sometimes the compounding does not happen annually. So in that case, effective annual rate becomes different. I'll explain with an example. If we have $100 today, then we invest for 1 year. Let us take the first case when we are doing annual compounding. The interest rate is 12%. So the person will get $112 after 1 year. So in this case, effective annual rate remains the same, 12%. Now let us take the second case for semi-annual compounding. In terms of semi-annual, we have 12% divided by 2. For 6 months, the interest rate is 6%. And we are compounding it twice. Compounding indicates we have invested $100 for 6 months and withdrawn the amount, reinvested it again for another 6 months. So what should be the value? At 6% interest rate, this amount will be 106. Now this 106 has two components here, the principal and the interest. But for further calculation of compounding, both 106 plays as a principal. So the next value will be 106 into 1.06, which will come out to be 112.36. So clearly the interest rate in this case will be 12.36%. This 0.36% extra is due to semi-annual compounding because we have compounded twice in that period. Similarly, take another case. If we are doing quarterly compounding, that means 4 times a year. So in simple terms, the formula will become 1 plus, this is the periodic interest rate, that is say 12%. If we are doing quarterly, there will be 4 quarters in that period. So 0.12 divided by 4, that is 3% to the power 4, because we are doing it 4 times, minus 1. So we get 12.55%. This interest rate is again higher than the semi-annual compounding because we are doing compounding 4 times. Similarly, if we calculate for monthly compounding, so the answer will become 1 plus 0.12 divided by 12, because there will be 12 months in a year, to the power 12, because we are compounding 12 times, minus 1. So this will give 12.6825%. So number is again higher. Before going to the concepts of continuous compounding, we will take one more case here, the same example. What if we are doing daily compounding? So this will be 1 plus 12% divided by 365, assuming there are 365 days in that year, to the power 365 minus 1, and the answer 12.7475%. So the idea is, the more is the frequency of compounding, the higher is the effective annual interest rate. But it will not keep increasing because the curve is exponential. So there is a limit to it. It will increase like this. And there is a final limit above which the interest rate will not increase. And that is precisely continuous compounding, where we are compounding every second, every fraction of second, and then continuously. So that rate will not be infinite. That rate will be limited by this number, and we calculate it as e to the power r into t minus 1. So in this case, e to the power 0.12, which is our interest rate, into time period. If we want to calculate for 1 year, just multiply it by 1 minus 1 equal to 12.75%. This is the maximum limit. This should be 75%. Now let us move to the next slide. This is simple. The future value and present value of a sum. This is nothing but the compounding, the future value factor. So if you multiply the present value with this factor, you will get the future value. And if you divide the future value by this number, which is future value factor, you will get the present value. For example, if we invest $100 at 5% interest rate for 2 years, so the future value will be 100 into 1 plus 0.05 square, which is compounding it twice. Like for first year it is 100 into 1.05. For next year this becomes the present value and again multiplied by this. So finally we get 110.25, which is our future value. This was the case for annual compounding. Similarly, if we want to calculate the future value of a single cash flow, as we said, we just divide it by the same factor, which is the future value factor. Take this example. If the discount rate is 6% and the future value is $1,000, which is to be received after 3 years. So we need to calculate the present value of this cash flow. What is the value of this money which is to be received after 3 years? The present value is, this number is divided by the future value factor, which is 1 plus r to the power n. The interest rate is 6%. The time period is 3 years. We get 839.62. This is the present value. So using this factor, we can comfortably interchange PAV to FV or FV to PV. So again, this is the relationship. If we have invested present value for these many periods, in the end the future value is going to be PV into 1 plus r to the power n. Now let us look at the cases where there are multiple cash flows instead of single cash flow like this. Firstly, there's annuity. It is the stream of cash flows which occur over a period of time. The same amount of money is to be received at each compounding period. For example, the ordinary annuity where cash flow occurs at the end of each compounding period. For example, if we have invested say $1,000, interest rate is 6% annual, and say we invest for 10 years. At the end of 10 year, we do not receive anything. Future value is 0. But at the end of every year, we receive a annuity or payment, say X dollars. So if we receive the X dollar at the end of every year till 10 years, that will be the compensation for this present value. This can be calculated. We will see the calculations in subsequent slides. The idea of the ordinary annuity is this. The annuity due is again the same idea. The only difference is the cash flow occurs at the beginning of the period instead of the end of every year. If we are getting the payment at the beginning of the year, it becomes annuity due. So we need to be careful in the question. If nothing is given, we can assume that it is an ordinary annuity. That is, the payment is given at the end of every period. But if it is given annuity due, we need to consider that cash flow occurs in the beginning of the period. Now let us take a numerical example to understand it better. Mr. A invests $1,000 each year at 10% for next 10 years. And what is the present value of the amount he will receive at the end of 10 years? The amount which he could receive at the end of 10 years should be converted into present value. Since we are going to use financial calculator in our exam, we do not need to remember the formulae. There are specific formulae for present values, slightly more complex than for the single cash flows, but we do not need to get into them. We can simply put these values in our financial calculator. The value of PMT, that is payment, every period is $1,000. number of periods are 10. I by y, which is the number of periods, is again 10. This is for compounding. Future value is 0. So we can compute the present value, which will come out to be 6144.57. So another interpretation for this annuity could be, if we invest this amount in a bank at 10% interest rate, we will receive $1,000 every year for 10 years. So to get this kind of payment, we should invest this much. Or we can also interpret it in another terms. If somebody has taken a loan of $6,144.57, today he can return the loan in terms of annuity. Every year the person has to pay $1,000 for 10 years. So this amount will include the principal, which is this, and the interest rates, whichever are applicable. So the concept of annuity can be interpreted in any of these ways. Now let us look at the same case for future value. If Mr. A invests $1,000 each year for 10 years at 10%, what is the future value which the person gets in the end of 10 years? Earlier we were talking about the present value, which is value today, and now we are talking about future value, the value at the end of 10th year. So again we can put the value in calculator in the same way. 1000 is the payment, n is the time period, this is the compounding period, again 10 years, because it is annual compounding, so I by y also is going to be the same. Present value is 0, so we'll compute the future value, which come out to be 15,937.43. For example, if somebody invests $1,000 every year at 10% interest rate for 10 years, in the end the person is expected to receive this amount. This is the future value. So this was the case for ordinary annuity. Now let us move to the case of annuity due. As we have already seen, the only difference between annuity due and the ordinary annuity is that in this case, the beginning of the period the payment of annuity will be made, while in the case of ordinary annuity the payment was at the end of the period. So in our financial calculators there are settings. In settings we can define the kind of annuity. It is for annuity due it says beginning, and for ordinary it says end, so we can select either of the options. For this case it will be the beginning, all other values are going to be same, and finally if we compute present value, this will be 6,759. We can see that this value is higher than the previous number, which was the case of annuity, ordinary annuity. Here it was 6,144, while if we look at the annuity due it is 6,759. So this says for annuity due the value of PV is higher. Similarly, we can see the case of future value. Again, annuity due, that is payment will be at the beginning of each year. All other numbers are same. Payment is 1000, period is 10, compounding is again 10, future value 0. So we'll calculate the present value. Sorry, in this case we need to calculate future value, and present value is 0. The future value is going to be 17,531. Again, this number is higher than the case where it was ordinary annuity of future value. Here it was 15,937. Now we are getting 17,531. The number is higher because we are getting the payment in the beginning of the year every time. So this is how we interpret the case of annuity for present value, for future value, and both the cases, annuity due and the ordinary annuity. We can simply put these values in the calculator and there is no need for getting into any formula. Now let us look at the another case where we are talking about perpetuity. We have seen in the case of annuity, there is a fixed period. Suppose we invest $100 today, we get a payment of say X dollar every year for only n number of years. So this is fixed. So this was the case of annuity. But if we want to receive this payment forever, for perpetuity, then the number will get small and effectively this will be only the interest rate. Naturally the question arises, what happens to the present value? Suppose we have invested $100 and we want to receive a perpetuity, okay, and the interest rate is 8%. So here we will receive $8 in the first year, again $8 in the second year, $8 in the third year, and so on. We keep receiving the interest. But what happens to the principal? What do we get in the end? Since we are assuming that this amount will be received for the infinite period, at that time the value of these 100 rupees or $100 will become 0. After say thousands of years, this amount will reduce to 0. That is why the perpetuity is calculated based on the interest rate simply. Now we can see the reverse case. If there is an asset that pays $100 at the end of each year forever at the rate of 8%, what should be the present value of this? So we can do the reverse calculation. We know the interest is 100, say present value is PV, and this is 8%. So 8% interest is equal to $100. What should be the present value? It is $100 divided by 0.08 and the value is 1012.50. So 8% of this amount is $100. So if this is the present value of the asset, it will keep paying $100 every year forever. This is the idea of perpetuity. We can calculate present value of perpetuity or the payment from the present value. Now let us move to the next slide. Okay, so far we have talked about even cash flows, where every year or every period we were receiving the same amount of payment. Payment was uniform or same for every period. But here in the case of uneven cash flow, the payment is non-uniform. For example, this says compute present value of 5 year. The cash flow is given below. This is invested at the rate of 10%. So for first year minus 2000, second year minus 1000, third year 500, this is positive. Again for fourth year it is positive, for fifth year positive 4000. So these are the cash flows. Some are outflows, some are inflows. So they are not even. For such cases we need to calculate present value of all these cash flows separately, and then we can just sum all these present values to get the present value of the complete cash flow stream. Here we can just put these values in the financial calculator. The payment, this is the time period. For first it is 1, for second year it is 2, 3, 4, 5 and so on. This I by Y, this is 10. So since the compounding is annual, so I by Y is 10%. Future value is 0 in all the cases, and we are computing the present value. So the summation will be this amount. So this is the simple case, just the summation of all individual present values. Similarly, we can have for the case of future values. So these are the uneven cash flows, and we have to calculate the future value. So we calculate future value for all the individual cases. Time period is 1. For annual compounding, the rate remains 10%. Present value 0. We calculate future values and then sum them up. We'll get the future value of the entire cash flow stream. So the only difference in uneven cash flows is we have to calculate it separately, and then we can take the summation. Now let us move to the last topic, which says when the compounding is done, the time period and interest rate changes accordingly. We have already seen it. This is simple variation. For example, if we are talking about monthly compounding, the M becomes 12. We have to divide the annual rate by 12 and multiply the period by 12. We have already seen when we were talking about semi-annual compounding, daily compounding, and finally the continuous compounding. Let us take this example. If this is the future value invested for 10 years, sorry, this is the present value, we have to compute the future value. The rate of interest is 7%, which is to be compounded monthly. So our N becomes 120 months and I by Y becomes 7% divided by 12. So 0.5833%. Present value is given to be 1000, and we can simply calculate the future value, which becomes 2009.66.